Hello, good morning, everybody. Can I move these slides? I guess, how does this work? All right, can everybody see my slides okay? I actually do not know. Yes, it appears so. Okay, so today I'm going to talk about data sources in SailPoint, and specifically the ability to create a reusable template data source that you can just let your analysts or whoever go out and create their own stuff. The goal will be that you can repeatedly deploy this to your companies or to your customer installations if you are a consultant. And the code will be made available publicly after we're done here. So here's some details about reporting in IIQ. The documentation on reporting has historically been kind of dubious, but with later versions in the 8.2, 8.3, they have started releasing a reporting.pdf with the documentation, which contains all of the information you would need. So I would encourage you to go look at that to learn about reports in great detail. But at a high level, reports are just task definitions. So they are the same thing as any other scheduled task. They just happen to use a task executor of type live report. They can have inputs. Your inputs are specified as standard IIQ forms. You have forms with sections and fields and so forth. Users can put whatever they want in there, and then that data will then be passed into the report as parameters. They also have output columns, because writing a report that doesn't produce a report is kind of useless. You're just wasting database resources. Output columns are implemented using the report column config class, which has a whole slew of options, including rendering rules and data type conversions and all sorts of stuff that play nicely with all of the out-of-the-box report types, and do not play nicely at all with the Java report types. So we'll be talking about that a little bit later. Reports have a data source. The data source is basically what the actual data for your report is. So it returns essentially a CSV. It's responsible for querying the data from some place, translating it into rows and columns, and then passing that back up to the report engine. Out of box, there are 3 data source types, and we'll talk about those in the next slide. Reports also store the locale and the time zone of the report owner. So typically you would create a report as a template, and then either a prod support analyst or a regular SailPoint user can then go into the reporting interface and create their own concrete report based on that template that filters down to the data that they specifically are interested in. And reports ultimately are rendered using Jasper reports, which is basically the industry standard Java reporting library. It is open source. It's been around for 20 years. So it is a good choice. It can render to PDFs and CSVs and Word documents and everything in the world. SailPoint offers PDF and CSV out of the box. On your report, you would need to specify a data source, and there are 3 of them provided in SailPoint. You have filter data sources, so these are basically going to execute something that you normally would put into a query options. So name equals this, and links.name, links.application.name in this set, kind of a thing. You are responsible for specifying the object type you want to return. So I want to query for identities, or I want to query for audit events, or something like that. And then your report column configs at that point are responsible for extracting properties out of that object. So you'll get back an audit event, and then each one of your column configs extracts some kind of a property out of that. It's very useful if your query can be expressed as a filter. HQL, or Hibernate Query Language, data sources can execute any HQL statement with customized inputs and named outputs and so forth. You can do a lot more with them than filter data sources. You can join on multiple tables. You can do all kinds of good HQL stuff. Again, very useful if your query can be expressed as HQL. Java data sources are just Java classes. They extend a particular interface. They are extremely flexible. They can potentially be much more efficient than all of the other data source types because you're doing everything in compiled code. But the downside is that when you change your Java class, you need to deploy it to the app server. It needs to be accessible in the base class loader for IIQ. So you would need to compile it into a jar and stick it in your webinf lib. And then anytime you change something, you need to do that again. So most of the out-of-the-box reports from SailPoint do use Java data sources because they are so powerful. But custom ones can be a little bit tricky. Let me check the Discord here for any questions. Nope, nothing yet. So what's missing from that? So IdentityWorks over time has found that our customers have reporting needs that go beyond the standard data source types. We do a lot, as you probably guessed from our other presentations, with plugins and plugin tables. We store a lot of data out there, and our customers would like to get some joins on those tables in a report. For this set of identities, which conflict resolution cases are assigned to them, that kind of a thing. And so forth. I see a comment here that you can include the Java class in a plugin. I do not. You couldn't before. The reporting engine could not load from plugins, but that may have changed at some point. Some people have wanted things that HQL simply does not support. So unions, union all, intersect. This data set minus this data set. Database specific SQL features, so JSON tables and XML types and parsing different stuff out on the server. They've wanted to use Oracle database links. So the IIQ database has a database link into a data warehouse or something like that. They've wanted to, for each row returned by the query, to do some sort of Java logic on it or bean shell logic. They've wanted to run sort of subqueries for each of these. So for each row that we get back in the parent query, split it out into 16 rows that ultimately get rendered. And then finally, the data conversion as far as timestamps to formatted dates, taking XML types and extracting a value via XPath from them or things like that. So what if we had a generic JDBC data source? Same data source is used for every report. So there's no need to deploy when you make changes because there is nothing to deploy. You write it once, you deploy it once, and then the reports simply reference it. Your analysts, rather than your developers, could be writing these reports. I have found, particularly at universities, that analysts tend to be extremely tech savvy in a querying the database sort of way. Inputs can be bind variables for safety. So we can do, select from the table where name equals bind variable, and that could be an input of some sort. We could add some fancy processing of the result set. So we can use that report column config and kind of hijack a lot of the stuff that it has out of the box. Maybe not use it the way SailPoint intended it to be used, but we can still use some of the variables and scripts and so forth that you can define in there to process the output. One thing we could do is if you have a JDBC connector to another application, we can reuse the connection data from that and do queries against other databases. And what we probably should do is make it as similar as possible to the HQL data type or data source type, so that somebody who is familiar with HQL reports can come right in here and write a SQL data report sort of out of the box. So here's what a Java data source does. You implement a particular class called Java data source. And then you tell your report that that is your data source class, and the reporting engine calls these methods which you have to implement. Initialize gets all of the input information and does all of the setup. After initialize, it calls next until you return false from next. So that is responsible basically for reading whatever the next thing is that the report is doing. So for an HQL report, it might be reading the next row from the projection query. For a filter report, it might be reading the next object out of the iterator. In our case, we're going to be reading the next result row from a SQL result set. And then after you return true, SailPoint calls get field value, and your job there is to translate your whatever you read in next, and you have to translate that into something that Jasper likes. So you're basically outputting something that goes into a JR field object. And then finally, when you're done and you return false from next, you can optionally implement a close, and you can clean up any connections or things like that. So this is basically what I just said, only in text form. So these are the things that you get in the initialize method. And the things that I have highlighted here are really the important ones. You actually get the live report object. So the live report has a lot of stuff on it, and you can take any of that stuff and do whatever you want with it. But you have to do it in initialize because you will never see this object again. The same thing as well is the task arguments. So these are things that are actually passed into the report, including user inputs and other data, any kind of configuration on the task definition. You only get these in initialize as well, and you will never see them again. Group by and sort by are also available. We're going to ignore those for the purposes of this presentation. Next usually follows this format. So on the first call to next, you will create some sort of an iterator over something, whether that's just a raw JDBC result set, whether that's a Spring object that wraps JDBC, whether it's something that is an iterator. And then for each call to next, you'll store the current row somewhere locally within your class. And then you'll need to implement get field value. And for your current row, you have to return fields one at a time. So some things we can do here to make our data source look like an HQL data source. So HQL data sources have a query and a query script. We're going to use those. It doesn't really matter. It doesn't care what you put into the live report definition. So we're going to use the query and query script. We are going to handle input arguments as named parameters. This is not something that JDBC reports out of box, but I'm going to have a named prepared statement class that will be part of this package that you'll see later to process named parameters into the appropriate bind variables. And then we'll do some report column config output stuff. So value class translations, date formats, XML parsing, rendering scripts with bean shell. You can always go back and add more later. It's pretty easy to do. But there are some things that we're not going to do just for simplicity. We only have 17 minutes remaining here. So things that I have done in my big version of this are post-processing of rows, database-specific data types like spatial coordinates in Postgres, stored procedures and callable statements, fallback columns, so if empty, doing subqueries, expanding things, and script arguments, which are part of the HQL data source, but we're just not going to do it here. Again, my big version does have all of these things, but we're not doing that. So this is kind of what a config looks like for a form. So the signature at the top there is part of a task definition, and it has inputs, and those inputs have names. So in this case, we have a first name to search for. This is going to be a very, very simple SQL query. Then you have a form. The form is separate from the report. So it's an entirely separate object that you'll just reference in your task definition. It's a standard form, like I said, and you just have to have a field in there that corresponds to each of your argument names. So first name, and then you have to set this value to this ref syntax. So the second time somebody pulls up the config for this, all the fields aren't just blank. And then here's our data source. So this is kind of the snippet view of our live report. So we have our JDBC data source report. You see the data source class is that object right there. The type is Java. And we have a query. So our query is just going to be selecting a couple columns from SPT identity for people with a particular first name. The report form is here. The columns down here, this is your outputs. So what we are going to be outputting is the name from the identity and a field called FP status. And I called it FP status because I wanted to show that it's technically different than the field that comes out of the query. That is given by property. over here. So full part-time is the thing coming out of the query. The field is FP status. The reason those are different is that, for example, let's say we wanted to take attributes out of here instead. So we get back the full big XML blob of attributes. You can have more than one report column config, excuse me, that references that same property. So they can do different things with those attributes, extracting different attributes, extracting attributes in different ways, fallbacks just in case an attribute doesn't have the values you need, and so forth. So now we're going to do some coding. So we're going to do what I said, capture all the runtime config, build and execute our query, and then future calls to next, just read the next row from the iterator. The first call to next is going to call a prepare, which you will see, and it does these things. I'm not going to just read the slide at you. And then the next thing that we need to do is, what on earth are we going to read from the result set? We could use the result set metadata here. Obviously, JDBC knows the column names that are in its output. The report column config, though, is going to be used for extracting these properties. We'll fall back to field if property is not present, but you should put a property. So let's look at some code. We're going to jump over here to IntelliJ, and we will open up our JDBC data source. So as you can see, this is a Java class that extends abstract data source, and the Java data source here is our interface that specifies what we need to do. So here's initialize. So basically initialize, I'm just kind of storing stuff for the most part. So we're storing the arguments from the report. We're storing the expected output columns. We are processing the query. So they can pass in a query, and if there's a query script, we will run it through there and potentially replace the entire query with something that the user wants at that point. And then the arguments get processed in kind of a similar way. We have arguments, we have parameters that you can specify on your report, and ultimately all of them end up getting put into the arguments object, which you will see later. And finally, we're just storing the report itself. So this is initialize, we just store stuff. We do some bean shell, but it's mostly just storing stuff. Finally, we call next, or finally, the reporting engine calls next, rather. If we don't have an iterator, we're going to go to prepare. The rest of this is extremely easy and straightforward, so I don't need to really walk through this with you. It's just doing does it have another row? If it has another row, go get the other row. So here's prepare. What prepare does after doing some logging is it has the query, logs out what the query is, makes a connection out to IIQ, and there's an important note here that I can talk about in Discord if we need to do that. Context.getConnection is bad. We make our named parameter statement, which was that class that I was mentioning earlier, and then we kind of loop over the arguments and insert them into our statement as bind variables. So set strings, set objects, set long, set integers, and set dates. So these allow us to handle a kind of wide variety of input types because we don't really know what the user is going to enter. And then we do our column names. So these are the expected outputs. So we're grabbing the properties out of this, and your query needs to have these properties in it. If you don't have these properties in your query, you will get an error because you will be trying to read something from a result set that isn't there. And then finally, we're going to return this magic class here that I may or may not have time to go through called result set iterator. It basically does exactly what you think it does. It translates from a SQL result set into an iterator over maps, and the iterator over maps is what is ultimately going to be processed by the reporting engine. So that's prepare. We're storing our iterator. We're getting our result set iterator back. We're storing it. And now we can kind of resume where I left off on the slideshow. So This is the result set iterator that I mentioned. This is kind of the details of it. I don't know that we will have time to go into it in depth here, but I can go through it individually after with anybody who wants. It just basically extracts the rows, saves the most recent row data as a map when next is called, and it handles a variety of SQL output data types. So when you query a database, obviously you can get back, strings and blobs and clobs and dates and timestamps with time zones, integers, booleans, all of that stuff. So we will handle all of those. We'll basically grab the type out of the metadata and do whatever conversions we need to do. In my big version of this, it also allows you to do different levels of conversions in here. So you can say that this column I'm expecting to be XML and I want to extract this attribute from it. Or I'm expecting this to be an identity and that's, I want to extract this object from something nested in the identity. We're not going to do that here. I probably will publish the big version of this at some point, but that's too big for this presentation. I'm actually not going to show the result set iterator. It's a lot of code and it isn't super relevant to the actual reporting part of this. So we're going to go straight to handling outputs. So for every output field, live report is going to invoke this get field value with JR field. It has a name, and that name will match our field name that we configured in our columns. So our get field value needs to do these things. We need to go grab the report column config, figure out which property we want, read the property out of our result set. If a value class is defined on the report column config, we'll do some limited translations of stuff. If the value is a date, we can support the date format. And if there's a render script or render rule, we will run that. So I will show you get field value now. We'll jump back over here again. So there's actually two different versions of get field value, and I do not know why. One of them takes in a JR field, one of them takes in a string. I usually just implement the one and have it forward on to the other one. So get field value string, what that does is it extracts the report column config based on the field name, grabs the property, and then we read that property. This current row is the last thing that we read from our result set. So this is our map representing our current SQL result row. So we have a value. Now we do stuff to it. So type translations. So if our thing is a string, we can do some stuff. If the value class is XML, we can parse it. If the value class is a date, we get the date ready for parsing by turning it into a date. And then if it is listed as a SailPoint object like identity or bundle or something like that, we can treat it as an ID and actually go out and look it up. So this allows us to write SQL queries that ultimately result in SailPoint objects. And then down here, we're handling our date format. So if a date format is defined, we just use simple date format to output the appropriate value. And then down here, we have our render def. So this is both render string or render scripts and render rules. And the value at this point has been processed. So we have either a actual date or an XML blob or a SailPoint object based on the field stuff that we have up here, or we just have our raw data from the query if we didn't do any kind of translation. But then this thing can do stuff to that value. So I can say, I know I have an identity here. I want to replace it with some sort of a script that I'm going to run on that identity. So that is what get field value does. Back to the presentation again. So for now, this is very basic. Some things that we could do to improve it in the future. And again, my big version of this already has all of this. We could support if empty. So out of box, like the HQL reports and the filter reports have an if empty concept. So if this property or column has no value, use this one instead. So if they don't have if they don't have a student school association name, go look at the employee department affiliation name instead, that kind of thing. We could support object path walking. So assuming we have an identity, we can just extract a value using a sequence of dot walking values like this, i.manager.assignedRoles.name, and we would get something back like that. I have a utility class that does this for any object, including XML and just sort of arbitrary value objects like identity and so forth. We could do bean shell pre-processing of the row data. So we could get rows back, and it turns out that we have some sort of complicated Java logic that we want to run to decide that we don't want this row after all. So we can do filtering of our rows both on the SQL side and in the bean shell side. We probably want to support the input locale and the time zones. So somebody who creates a report that runs one of our queries and gets back a date probably wants to see the date where they're located. They don't want to see the date around the world. So we could do that locale and time zone translation for them. Or we can automatically translate extension attributes. So I don't know if you noticed in my query, I was directly referring to extended one. What we could do instead is refer to it by its attribute name, so department, and have the preprocessor of our query translate it to extended one. So that's what I got. Thank you for watching the presentation. I'll be available on Discord for the rest of the day. And once I get this code cleaned up to a publishable level, I will push it out to the IdentityWorks GitLab site where we've been pushing all of our other artifacts.